Interweaving today, and we're streaming right now on Twitter, Facebook, YouTube, LinkedIn, all over the internet. We're everywhere, and this is your thing as well. It's live for exactly that reason. So if you're on Twitter, something comes up, just drop in a comment. We'll try to bring you into the conversation. It is a live chat, so it involves all of us. So we'll have a quick round of introductions and we'll kick straight into it. I'm Atul, an online maths tutor teaching Key Stage 1 to Key Stage 5, independent sector, state sector, homeschool, etc., etc. So over to you, Helen.
Thanks, Atul, for having me again. I am also a private maths tutor, focusing in on GCSE and A-level maths. I'm based in North Wiltshire, but I tutor internationally and have been doing so for 12 years now, I think it is. So that's me.
Welcome back. It's your second time in a row. And third, I think, even, right?
Yeah,
third.
You'll be sick of me, Atul, soon enough.
And on to you now, Karen.
Hi, I'm Karen. I was here last week as well. I teach secondary school maths, year 7 up to upper 6 further maths, and I've been doing so for 25 years, and I'm based in Surrey.
And again, welcome back to your second Maths Chat Live in a row.
Yeah.
And finally on to you, Nathan.
I'm Nathan. I'm a maths teacher in Nottingham. Been teaching for a bit less than 25 years, and I like making tasks, and a lot of them use interweaving. That's, hopefully what we're talking about today.
Excellent. So, this is based on at the MathsCon 28. There was so many great workshops, and this time they were not all recorded, so I had major fear of missing out myself. So I'm like, in some ways, for selfish reasons, I'm inviting people whose workshops I missed or whose workshops I attended, like yourself, and continue the conversation, because that's what these conferences are supposed to do. They continue conversation and keep going, and this is never finished. So when I was writing the blog post, I kept mixing up interweaving and interleaving. So I guess my first question is, what is interweaving and how is it different to interleaving?
Yeah, well, I'll take this one if that's all right. Let's start with interleaving, because interleaving is interesting because nobody knows what that is, and every time it's mentioned it causes a bit of confusion, a bit of discussion, because there's a few competing notions about it. That Alex Blanksby on Twitter has done a very, very long thread, which is really interesting, talking about the nuances of it and its history. But I'm on the other side. I'm talking mainly about interweaving, which is about bringing different topics from across maths, maybe even across other subjects as well, together into one task, into one question, and looking at how those connections can interweave with one another, how you can explore maths a bit more deeply by bringing different topics together, because so often it can feel like just a load of isolated different topics. You've got geometry, you've got number, you've got algebra. In algebra, you've got equations, you've got identity. Bring things together, show it's just one subject. I think there's a lot of opportunities there for really interesting maths to do.
Yeah. So I suppose interleaving would be, as far as I understand it anyway, it could be a way of use a computing analogy, like serial, one after the other, and interweaving is kind of parallel, where all of them are happening at the same time in one task.
Yeah, interleavings are typically a bit more about breaking things apart sometimes, just to really separate between quite close concepts. Like if you're teaching air and perimeter, make sure you're doing that at the same time so you can draw out the differences between them. Or it's about a way of kind of spacing. So if you're doing a worksheet, bring in different topics, but have them separate questions, just so you can bring in different things in a bit less interwoven fashion, but more building in ideas of retrieval, of spacing, things like that.
Yeah, so that's how I would interpret interleaving. Definitely how our school interprets interleaving is more of a spaced repetition. Sort of, you're doing a homework sheet of 10 questions and they're on 10 different topics. So you're not doing the exercise from the textbook, which is 10 questions on the same topic. So there's a moment of disconnect where you're like, oh, I've got to stop and think about what this question is about. And definitely there's some some ideas out there that suggest that just putting one question in the middle of an exercise that's on a different topic is enough to bring the students to a stop of just being automated in that, oh, I'm adding fractions, oh, I'm multiplying fractions. I don't need to have a common denominator, and then breath and back in again. And so that's how interleaving often gets used, in a sort of disconnect sort of way to break their automated thinking, to make them stop and start thinking again.
That's definitely how it's used on quite a micro level, but broadly it's also seen as just an alternative to blocking. If you're sequencing a curriculum, I think instead of doing, we'll do a term on algebra, then a term on geometry, make sure on that scale you're mixing things up. It often comes into things like sports practice. Instead of spending a whole day practicing your kicking, do a bit of kicking and a bit of throwing. I'm not a sports person, but there's a lot of different facets to it. And it's very interesting, but it's not as good as interweaving.
So I think a really good way to demonstrate what interweaving is would be to, I'm happy to talk about one of your tasks that I've done, or if you wanted to share a task, either way, whichever you think is better for you, Nathan.
No, you go ahead.
So I did the L-shaped area fraction task with my year 7s last week. I have to say, a stunningly designed task. How many hours you must have spent with those fractions to make the answers come out so lovely. I was just like, I didn't really pay attention to the answers. I was like, oh, I'll work them out as we go along. And then I was like, oh, these are really rather lovely. So the idea is it's like just reviewing area with the year 7s.
Share screen for a second.
Yeah, there you share the task. Then they knew how to find area of rectangles, and they knew how to find compound area of rectangles, and we've just been doing integer lengths, but we'd done fraction work the week, like the sort of topic before, we'd been adding and subtracting fractions, and they'd been multiplying fractions previously. And so actually that was really nice task to just keep doing what we'd been doing on the previous topic. So like, actually, you know what, you need a bit more practice at adding fractions and multiplying fractions, but I really don't want to give you another sheet of them. And we've just hit area. And so actually, just a lovely way of hitting 2 sets of practice in one go, really. Because some of them are nicer to do by splitting, and some of them, the way you've labelled the sides, some of them are nicer to do by splitting, and some of them are nicer to do by subtraction.
Yeah, that's what I love about this task. I've used it with year 7, I've used it with year 11, and a few different classes in between. And I love how with every question there's about 3 or 4 different ways you could do it, and one of them's always best. It's not always the same method on each question. There's always one way you don't really need to calculate the other sides necessarily.
Yeah,
and you can use your fact about perimeter. The perimeter of the L-shapes are just the perimeters of the enclosed rectangles throughout. If you spot that, you save yourself a lot of time. And with the areas, as you said, you can subtract, you can split and add. There's so many different things to explore with it.
But yeah, I think that gives you quite a nice starting example of what interweaving is talking about, because you don't see those type of questions in textbooks. You would just see area questions, and you would just see fraction questions, and you might have some people who like using it like I was, is that I'm now teaching area, we've done fractions, let's use it. But you might have other people who are we've done area, we're now doing fractions, let's use it now to recap the area work. So it's like, with the other advantage of the task is there's no fixed point when you can use them. You can use them at the end of one topic or the other topic. Or I think they've got potential to be amazing as revision resources as well, a task for revision, when you're like, right, I need to revise everything I've done this year. This one task hits 2 topics in one go, which is, I think that's also a really nice point for them as well.
Isn't that the way that they often, particularly when we get higher up into the GCSE papers, the harder questions do interweave the topics together, don't they? They mix in a bit of this and a bit of that. They might do fractions with an area, or fractions with something else. Fractions with probability, I know, is when we know that we're expecting, because if they've got a tree diagram and we've got fractions, we've got our fraction skills and our tree, and they come in together. It's the same question, 2 different bits of maths, and actually getting students ready to see that this could be, you use this skill here and that skill there and a bit of this. I was doing length of a line with a student the other day, and I was quite chuffed. He spotted Pythagoras straight away, even before I said. But that leads to surd work, and you're mixing Pythagoras with surds, which he hadn't done a lot of yet because he's a younger year student at the moment. But I was just thinking, well, actually, yeah, that's logical. You'd end up with surds if you've got Pythagoras and you don't have a nice number. And who wants to use a decimal if we don't have to? Because they're horrible. But there we go. It was just, that's how we're going to see maths, isn't it? As we get further up and we jump into A level and the questions are much longer and much more interwoven. You've got a bit of that and a bit of this all over the place. So yeah, it's great to be able to do it earlier and in ways with I've got to use that worksheet, those questions. That's on my hit list next time. I've got to do either fraction or area or both.
No, you're absolutely right. And it's increasingly common to see these sorts of questions on exams. It's, as I pointed out in the talk, it started off with the infamous Hammer's Sweets, where that's a classic quadratics and probability interweaving. And since then, they want to find more and more ways to bring things together. So the more they're prepared for that, the better. But they're not just doing it as a pragmatic, it's for exams thing. I think it allows you to understand the topics on their own a lot better as well.
I was thinking when Helen mentioned surds, and you've got some tasks where you'd never normally use surds, or never normally see surds. But again, practicing surd arithmetic is one of those ones that is just most of the time just a bulk standard exercise. Right, root 75 is simplified surd, add together root 75 and I'm trying to think of another one that'll work, root 125 maybe, possibly. Should not try and make these things up on the spot. But actually, I think Nathan's you've got a averages one, haven't you? I think.
Yep, I'm getting up.
Which is a similar, there you go. You're finding the mean, all of those sort of. There's your arithmetic practice for surds at the same time as reviewing your averages knowledge. And actually, that appearing in an exam paper would take us all completely by surprise. But that doesn't mean you shouldn't be using this, because it's just a nicer way of practicing basic surd arithmetic while reminding them of some other skills at the same time.
What I love about this task and the similar ones with sequences and other averages of different types is they've got to decide what calculation they need to do. It's not just a list of add these, subtract these, multiply these. They need to know when they need to divide, they need to know when they need to add. And often I find with doing, say, mean or median with just normal numbers, is they do so much of it subconsciously, they don't really know what they've done. They don't know that they've ordered the numbers. They know they have to order the numbers, but they haven't really consciously thought about it. Whereas when you chuck surds inside, they need to think so much more deeply about what they're doing, both with the averages, what calculation they have to do, the fact that they have to order to find the median, the fact that a range is a difference. They've got to think so much more deeply about that when the surds there. And they've got to think so much more deeply about surds and what calculation they do with those, when they need to simplify, why they need to simplify, why they might want to unsimplify. I think that's what I like so much about this sort of interweaving task. There's multiple ways you can do it. A lot of them, I think, reduce just to really how chaining together problems, and you just put a weird number in and hope for the best that it's an interesting problem. Whereas these, I think, work both ways. They build your understanding of both topics at the same time.
Mm-hmm. Could you fill up the space a bit more while zooming in?
I
just on
can,
Twitter,
yes. Sorry, it's on a very big monitor.
Yeah, on Twitter it's a little bit small, but I think just for our viewers.
Plus.
I'm just looking at Twitter. Yeah, perfect. That's really good actually, because I think one of the other things you did in the MathsCon 28, you mentioned Hannah's Suite. I was going to mention that, and you already did that, and that was a classic example. But it's already got me thinking that if ordering is a skill set and then finding the mean is a skill set, there is also that classic case where you get fractions and decimals and whole numbers, and that's one of the tasks is put them in order. But you can put them in order and find the mean as well. So that's immediately two things that you've interweaved. Yeah, and that's the idea of maths really. Eventually, we want to make the connections between the things, and you kept mentioning in that talk, you had that grid, I think, with lots of bulleted lists, and all of them had, like, all four quadrants had make more connections, more connections.
Yeah, it's on the NCETM's 5 big ideas for teaching mastery, or mastery teaching. And yeah, they split it up into these key ideas, and every one, making connections is a fundamental part. And that is true to what maths is. And as I said in the talk, it's something that is so obvious to us, that these sort of bits are all connected, that there's an underlying pattern and structure to everything. I don't think it is obvious to our pupils sometimes. I don't think they see it in that way. They don't notice the connections. They don't see the fact that speed, density, and pressure are all the same, unless we make them reconcile themselves with it, force them to think about those connections.
Can I ask you a question about this task?
Yes.
Did you start with the integer parts and then just put the same root after them and then unsimplified surds? I'm just intrigued because
I don't remember.
No, okay, fair enough. Without scrolling down to are any of the medians over 2, or have you managed to pick your 4 ones so that they're all? Oh, they are. Okay. Oh, and okay.
Yeah, there's definitely some interesting ones in there. They're not just surd multiples of integers. They do. I
like K.
Bring in together different ones.
K's quite nice. That's been quite well.
Negative numbers thrown in as well.
So.
Yeah, and that mixes your root 2s and your root 3s.
Yeah, but you've picked your middle 2 so that they're the same root, so that the median doesn't.
And the root 2s cancel out when you find the mean as well, which is.
Yeah. No.
That is one of the big issues with interweaving, is creating interwoven tasks. It's hard. But I don't want to say that. I don't want to sound like I'm self-congratulating there, but they take a lot of time. They're really effortful, which is why I'm so keen on having people share them, having them freely accessible. Because it's hard as a teacher to find the time to make these bespoke for your classes, because you can't just come up with a list of questions, because the answers so easily become horrid.
Well, yeah, you just wrote down 4 surds. The answers you'd end up with, you'd be like, well, I haven't really practiced anything there apart from writing down 4 surds. So yeah,
we all know that making up numbers, making up surds and things like that on the spot usually ends up with a horrific answer, and goes to planning what you need to write as a benefit.
Yeah.
I've just tweeted as well that it relates in. Stuart last week was talking about highly effective teaching, and we were on, and his talk at Maths Comp was about the big picture and making those connections. In his case, it was what do we need to teach before we teach, if that makes sense, and the underpinning skills, and where do we go from here, how do we use it, putting it into its place within maths. Whereas this is, well, we can use these here, and this bit comes in, and it's another way of making those connections, which is just, I think students are pretty amazed sometimes when they realise that actually maths does all work together coherently. It does surprisingly all fit, and we can use this bit and that bit. As I said, this student that we were doing length of a line and went, it's Pythagoras. Wait a minute, don't we do Pythagoras with triangles and not graphs? And then straight after, later in the session, we were doing midpoints, and that's averages. I mean, it's the average of 2 points, but it's not. And as soon as he got, wait a minute, that's 3 different topics we've just done on one little bit of coordinate geometry. Being able to link in and do things. I'm going to be nicking this one for surds as well next time I teach averages. Sorry, Nathan.
That's what they're there for.
They're definitely worth.
There's also a sequences one that I like, continuing arithmetic and geometric sequences that, again, it forced them to use every bit of surd arithmetic, but you're never told what bit to use. I like that.
I quite the inequalities with standard form. That was I think you may have put that together because I asked you to. Near enough. I was like, I want some different questions on inequalities, and we'd just done standard form, and so solving linear equalities, but having the having the algebra bit in standard form, and
again, I love that task. I've used the equations version of it to make an inequalities task. I changed the equal signs to inequality signs, but the equations version of it works so well with my year 10s that are pretty good at solving equations, but could be better, and they struggle with the harder ones. They're pretty good at standard form, but again, struggle with the hard ones. but doing this equations with standard form forced them to really think hard about. I think I should be screen sharing now. How they solve equations. Like it made them. They got so fluent with solving equations they'd stop thinking about what they're doing, and this forced them to actually think, how do I solve question 1?
Did you do it non-calculator or calculator?
Non-calculator.
Non-calculator.
Yeah,
I mean, that would be.
They're all quite nice multiples, I think. Hopefully.
I find students don't like the calculations with standard form. I mean, turning numbers into standard form and going one way or the other—that's a skill they developed quite early on. I can't remember where in the curriculum it first introduces, but it's certainly there a few times. Whereas the calculating with them just seems to throw them for some reason. Maybe it's the mix of using the indice rules and then having to do the numbers separately. Well, not separately, but we apply the rule to the indice and not to the numbers, and it just scuttles them. And when we've got adding and subtracting, and you've got need the same to have the same power of 10, then they've got to.
Yeah.
I don't know what it is. There's a blockage there for students. At least many of mine go. And I did one the other day with a past paper, and it had a standard form non-calculated question, doing a calculation, and they just went 2.52 times 10 to the 5 divided by 4 times 10 to the minus 3. So they had taking away a negative indice. They didn't like that one.
And I get it. I find it quite hard, especially the ones where you're having to convert, like, so they've got the same power of 10. I find that sometimes a bit. I really have to concentrate. Think, okay, which bit's getting bigger, which bit's getting smaller, that sort of thing. It's something that I've struggled with, and that's why I like these tasks. It's made me so much better at it. And deliberately, the first column 1 through 8 are all ones where you don't need to convert, particularly between powers 10, because I want them focusing on the equations bit really. And that idea that you can treat 10 to the power 6, saying question 1, just as a counting unit.
Yeah.
You've got 5 10 to the power 6, you're taking away 3 10 to the power 6, you've got 2 10 to the power 6. And that idea of a counting unit in these questions is so helpful. No, they don't at first.
That is a takeaway. They say, I've got 5 to the, I'm going to make that 5 million, and I'm going to take away 3 million, and that's too big for my head to handle on a Thursday night.
I was marking your 10 papers today, and I'm not going to blame myself for this, but there was a question, I think it was adding standard form. It was 4.7 times 10 to the power of 18. It's like charges of a subatomic particles. And they wrote out 47 followed by 17 zeros. But it would be negative, so it would be small, wouldn't it? But 0.0000. And I'm like, oh, come on, you've got to spot the shortcut halfway through writing all these zeros, right?
But there's an interesting, for example, question 1, there's an interesting link there to A-level when they're given questions and told that like the units are in thousands, and they don't, and then later in the question, they're given they're given the number in thousands and asked to substitute back into the formula, where in the formula it tells you everything's, they found a constant, and then they substitute in the wrong value because they haven't taken the factor of 1,000 out.
It's sort of like the number going in is 5,000, and if it's in thousands, then it
should have gone in. Yeah, it should have gone in as 5. Especially when they found it was an exponential, and they found k, from using the numbers without the thousands on it, and so when they've done the logarithm, they've factor of 3 out, and so. Yeah,
you're really helping them with physics as well. I mean, at GCSE physics, they'll deal with things like megajoules and kilojoules, which is 10 to the 6 and 10 to the 3, and then the standard form joules. So this is actually helping them with that as well, and they'll have to think in different
especially for A-level physics, they need to be so good with calculation of standard form for dealing with big numbers and small numbers and charges and distances and astronomical units and parsecs and all manner of wavelengths of light. They need it. And
maths is everything, isn't it?
Yeah.
Maths is everything. Underlines physics.
Spanish poetry too, I think. Yeah,
absolutely.
Why not?
If I make some Spanish poetry that's got standard form in it, and I'll buy you a drink at Maths Comp next time.
Haiku with 3 times 10 to the power 4 syllables in the first line.
So how do you go about making these, Nathan? Because I wasn't at your talk, so
yes, it was one I wanted to get to. You'll have to do the talk.
I'm going to share the PowerPoint, aren't I?
Yeah.
Well, you can wave your arms instead. That works too.
Just do it again next MathCon.
I'll do both. I'll share the PowerPoint.
You can put us all on the spot and get us to make those questions like you did in the MathsConf.
That is a good idea. Right. I've entered presenter mode, which means you've all disappeared.
I'll get my piece of paper ready.
Okay, and that's the one.
We're taking this seriously, are we? Okay.
Is that working?
Yeah, we can see.
So this is what you want, isn't it? It says how in big words, big letters.
Well, I want how Nathan does it. I don't necessarily need to do it myself.
Not on a Thursday evening on the second week. We're not allowed to talk about how you're on holiday.
You're on holiday and the rest of us aren't.
Yeah, exactly. Anyway.
There's kind of two stages, of course, to kind of up with the interwoven task. You first need the idea. You need to know what you're going to try to interweave. And that's what I focused on with these slides, is how to know what makes suitable topics to interweave and what makes unsuitable topics to interweave, and come up with ideas for that. And I kind of split bits of maths into these three different groups. I think mainly I do this subconsciously. It was only through really thinking about it for the talk that I came up with these as quite specific categories, but it's kind of trying to work out what goes in my head when I'm coming up with ideas. So there's the idea of inputs, which are the sort of the numbers you can chuck into a question. Fractions, decimals, standard form, surds, negatives, negative fractions, negative decimals, all those sorts of things that you can push into a question. And you can imagine like the L-shaped areas. You could do that with standard form, you could do that with surds, you could do that with decimals, you could do it with percentages, controversially. You could chuck a lot of different forms of numbers into that question. Then you got the processes, which is the actual maths you go about solving the problem with. That might be dividing things into ratios. It might be solving equations, showing identities, bits of algebra. I've also put sequences in here, and that's a type of task which I want to explore in a bit more in depth, where you can form sequences from questions. And I kind of thought about that with one of the investigation tasks, is the idea of having it give you a sequence of numbers and process to find the nth term or whatever of that sequence. So those are kind of ways you can process the information in the question. And then you've got the context, which are like the surface level parts of the question. These could be your areas, your perimeters, your angles, polygons, averages, rounding, and together these can build to give you a task or a question. I wrote these just listing them as they came into my head, and I thought, well, let's set myself a challenge and set the people at the talk a challenge to come up with some tasks with each of these. So it's taking the top row, looking at fractional, equational, geometry questions. And there were some really nice ones that were shared. People tweeted photos after the talk, and that was really nice to see. Here's one I came up with for that. There's some fractions. You have to solve an equation. The context is a geometry question. Of course, there's so many other variations you could do on this. It doesn't have to be a circle theorem. It could be angles and parallel lines. It could be an angle in a polygon. It could be any geometry thing you want. It could be the area of a shape. But that idea of forming an equation, which is a quite typical thing to do, form an equation in a geometry context, solve it. But you don't often have fractions in there as well. So that's quite a bronze level interweaving.
So that uses all three columns, though.
That uses one from all three columns. I usually wouldn't. I'd usually only choose two.
A lot of your tasks tend to look like initially you've only started with two columns rather than three.
This was just kind of testing boundaries.
Oh, no, fine.
What you could do. There's surds, ratio, and averages. I had 5 seconds to think what might be about to appear on the screen.
Well,
I mean, I think the others know because they were in the talk, right?
I was in the talk, no. Only I was in the talk, so.
Oh, okay.
We've got an irrational amount of money being shared in the ratio 2 to 3 to 7. The mean amount shared is the root £128. What's the size of the smallest share? Yeah, I'd only probably use 2 of those in a type of things in a question. Like I might be just
my head hurts.
Using means and ratios maybe, or dividing surds and ratios. Oh, dividing surds and ratios, I do like that idea. But it shows nicely the process, dividing in the ratio. The context is an averages problem, kind of, and the input number is a surd. That's nice. And finally, standard form sequences and rounding.
That's cool.
I really like rounding as an interwoven trick, because it allows you to do things the short way.
Yeah.
Find the answer, then round it, but also allows you to find shortcuts, which I like, to think about what will the answer be, what do I need the answer to be for it to round something, to think, oh, well, it'll need to be 2.5. I like that. So that's how you can come up with the ideas, is just think about these different topics and how they can act differently in a task. How you actually come up with the questions themselves is a bit of a trickier one, and one that's a bit personal to me. I usually use Excel, just because that allows me to adjust the values and see the answers pop up, so I can tweak until I'm perfectly happy with the questions. That's what I find easiest. Obviously, I make everything in PowerPoint for the kind of the visual presentation of it, but it does take a lot of tweaking. I think no task yet has survived first encounter with a class. So whenever I've used one, I've always changed it afterwards to see how they react. And
when you use it with a class, so I just let them loose, my year sevens, because I was like, oh, I was relatively confident they knew what they're doing with compound area. They would be fine with the compound area, and we'd done fraction recently enough that I was like, yeah, I reckon I can just let them loose, and there might be the odd one or two who flounder a bit, and I was like, right, I went and got a mini whiteboard and said, right, just draw it a bit bigger, and let's split it up, and you can work out some missing values. But I didn't really go to them, oh, this one's just a bit different today. How would you go about it?
I think it varies massively for the class, for the task. Certainly with some classes, I'd love to just have at it and see what happens. And if they drown, jump in after them and rescue them. If they don't, then let them keep going. With other classes, I do take it a lot slower.
Because I can see
go
how...
through that first example as a class. I do a few more like that. Like you saw the equations with standard form with my slightly lower attaining year 10s. It didn't look like that. It was 10 questions like question 1, then 3 questions like question 2, then a couple of questions like question 3, just to give them that opportunity to get their head around it. And one of the big things I push for with using these tasks is it's not about the novelty. I quite like the idea of the problem solving, here's something new, how can you think about it? I think there's benefit to that, but I think there's even more benefit to when it stops being the novelty and they start just solving the questions, and they get used to the format, they get used to the topics being interwoven, and then they can be thinking deeply about the topics, and that's what I want them to be doing, is thinking deeply about the topics. And in those cases, I do take it slowly. I do model, because a lot of these questions are really long, like to solve. Like your answer will be many, many steps, and it'll probably be the longest questions I've seen.
Yeah. Showing
how to structure that so they don't just get lost in a mist of workings out is really important. So with some classes, there's a lot of we do before any hint of you do.
And so that's why because there's a lot on each slide. There's what, 20, no, not quite, probably 20ish, is it? Is there like 10 and 10, 2 columns of 10, something like that on quite a lot of the slides? So you're looking at a decent number of questions there that they can get stuck in, and it stop being not only like, I'll do 5 and then try something different sort of thing.
Yeah, I do. I try to make as many questions as I can, and then I select the ones that I use. I don't tend to just use the task as is.
So you take the PowerPoint.
But I choose the questions that I want from that as kind of a question bank, showing the easiest it can be, or most straightforward it can be, all the way to the hardest it can be. And I'll choose the selection of those that's most appropriate for the class that I'm using it with.
So one of the things that occurs to me that people might be thinking about this is, because I just said, I used it at the end of the area, compound area, having just taught them fractions. So both the topics were relatively new to the students. And there is, when we talk about sort of interweaving, often people will think of that as a problem solving style task they've been given. And there is we often feel with problem solving that the maths they should be using should be something that they've done, that they're really secure at. And how do you feel about these? Do you feel about them as, yeah, you're secure at that topic, do it? Or do you feel...
I think, let's look at the standard form equations one. If you can't add and subtract with standard form,
yeah,
or if you can't solve linear equations, that task will have no value to you.
Yeah.
What it, I think, is great for is that consolidation. Is the people that are mostly there, but not there yet. So I don't think it is a 2 years down the line, then use it, although I think it'd be beneficial even then. Mm-hmm. I think it is a towards the end of the unit, when they've got a bit of practice, they've got the bit of fluency there that will get to the point where their brain is no longer quite firing on all cylinders when they're doing a question. It's a way to shake it up, force them to rethink about what's going on.
We come back to one of Stuart's points last week was we're doing a lot of measuring in teaching. We need to get a measure of where they are and then tweak our approach accordingly. And I think from mine and Helen's point of view, we can do that with one-on-one sometimes. And if I feel I'm thinking as well, like on the spot, sometimes it's quite useful to come up with a bit of interviewing if it's beneficial to that tutee in that moment in time, in that from based on what they've done. Something like, I'm just thinking of looking at the list, equations, geometry. You showed it with the circle theorem one, but you can have it with a rectangle where one, you have an expression 2x plus 1, another expression, or just a number, so you form an equation and solve. So but you'd have to know that you've done that kind of similar things with that tutee before you've done forming equations, and the element of surprise is only when you put the two together. And that's probably what you want them to do, right? You want them to, like, I've done this, I'm fluent in this, and I'm fluent in that, and here two different ideas are connecting, and that's where that kind of thinking and interconnecting and far transfer happens.
Although it's about timing it right, so that the second topic that you're interweaving is something that they are still fluent at. That's, there's and we're coming back to the highly effective teacher again, aren't we? And when do you know is the right time to give it to the students, so that they're not going to sit and go, I've got to teach them how to solve equations again, because although we've just finished standard form, turns out that they can't remember how to solve 4x plus 2 equals 17 efficiently. And that means that actually this task that I've decided I was going to give them on both is not as good as I thought it was going to be.
To that end, you mentioned to use them for revision. I have used them for revision with year 10, with year 11 a lot. And what I found great where they needed that reminder was just presenting the two bits of the question separately, and then presenting the interwoven question, and force them to write, like, you can do both bits on their own. Now you're just doing both. And
I mean, I
presenting it that way can help.
Yeah, using them in the classroom when the right time occurs, I think they've got so much strength and depth in terms of what the students will be seeing and getting out of it. But I also can see how, when you're a little bit short of time for revision, the thought that you can go, here we go, we've done 2 topics in 4 questions, rather than having to do 2 topics in 8 questions. And
also the other benefit is if you're using them for retrieval, to keep on revisiting those topics, especially ones like the fraction calculations. I don't know, we do fractions quite early in our scheme of work, and they might not divide fractions again for quite a while otherwise. And this is a way of doing retrieval that isn't in a starter, and doing retrieval starters and is a bit controversial, and some say it's a bit of a waste of time. And this is a way of getting that same goal of revisiting those topics without it taking up more of your lesson on its own in starter when you want to be delivering new content. So,
which is your favourite task on the website, Nathan?
Oh, what a horrid question to ask. Choosing between my children.
Yeah. You must have a favourite one, right?
It's like asking me what's my favourite song.
No, I'm not going to answer that one.
So all the ones on the website you've used, or not quite?
Yes, I have. Not in their entirety. I've used bits and pieces of some of them.
So let me change that question then and say,
I really like the converting units of area with standard form 1. And I can say that quite nicely because I didn't make it. JSHMTN on Twitter, Josh Martin made it. And I think I think it's a really nice way of linking two topics that are kind of obviously the same, like converting units of volume with standard form is so natural to do. And the questions are so nicely asked, where it's broken down into steps and they build together each one to the later parts of the questions. I could share the screen again. I don't really want to. Stop share, restart share, do that one. Is that working?
Yeah, nice.
Yeah, I really like this task, especially that final question 4, I think is.
This was great.
It took me a while to word it correctly. We're ignoring the typo in question 1C, which I've been meaning to correct for a while. But it should be 8,000 square meters, not 9,000 square meters.
Okay.
But other than that, I think it's fantastic.
That would make that slightly easier, that one, if it was 8,000.
It would make it slightly more relevant, yeah.
Given all the other numbers in the question. Yeah.
Yeah.
That's lovely. That's the sort of thing that comes up in both GCSE and A-level physics as well. Very common way.
I don't think the sole of my shoe comes up in A-level physics very often. Not that I tutor A-level physics, but...
Well, pressure calculations.
That's the heel of my shoe, and that's painful if I'm wearing stilettos. But yeah, certainly the moon area.
I also really like, and what I want to make more like, is the interwoven investigations task at this one. Karen, did you say you used this one at some point, or something similar to it?
Yes, I did. I think
it's a lovely.
Yeah.
I've used it with almost every class I teach, I think, by this point. Just so I really like it. Not always entirely relevant for the scheme work, but better than the pirate game for the last lesson of term. So I really like how it brings together two things that seem very different, volume and factors, and shows that there's an underlying connection between them with a bit of a twist at the end.
Is it something we should see more of in the curriculum, to ask the controversial question?
Interweaving?
Interweaving
Yes.
investigations into different areas. Because when I did my GCSEs, not admitting how many years ago that was, we had to do a piece of maths coursework. I think we did ours on Pythagorean triples, I seem to remember. And so we're talking a while ago, and then it came out. And as far as I'm aware, there's no syllabus, GCSE syllabus in the UK that has coursework in it. Do we miss out then on investigations because we don't have that in our GCSE? Most GCSE questions aren't interwoven. Let's check my grammar on that. It is interwoven, isn't it? To get the correct grammar.
I hope so. I was spending money on the URL.
There's a reason I don't teach English. That's it. There are some questions we quite regularly see the algebra and the geometry one in an angles question quite often, and sometimes we see other bits of ratio and algebra and sometimes make an appearance. But most questions, particularly on the foundation tier, are find this as a product of its prime factors, or find the area, or do this calculus. It's very basic, just do the question without interweaving. Whereas the coursework and the investigations interweave it more, if that makes sense.
And they do a bit more real life contexty sort of things, which is another form of interweaving, really, bringing in real life considerations.
I've just talked about the moon and my shoe, so
whether there's I'd like to experiment more with these sorts of investigative tasks. It's not something that is in my particular domain of comfort.
It was
comfort zone. That's the phrase. It's not something that comes naturally to me. I quite like the list of questions approach to teaching personally, but I want to try more of this because I think there's potential for it to explore.
The list of questions certainly takes pressure off, doesn't it? In many ways, and it doesn't require us to be necessarily quite so creative in how we mix the topics up and weave them together. But just simply, another tutor introduced the Josephus problem. I don't know if you've come across this one. This is, as far as I remember, it was a couple of years ago that she introduced it, that the Roman centurion goes around and cuts the head off of every other person. So where do you want to be sat in the circle so that you're the last man standing?
Oh, yeah.
and it's an algebra investigation, isn't it? And you don't want to be the even. It does one thing. If there's an odd number of people, it does something different. That would bring in so much creativity for students and for different ways of approaching. It just strikes me that we don't get very much of that necessarily in the curriculum.
I think you have to be careful with the level of maths that they have to use, because doing an investigation is really cognitively demanding. So
with the Diddy one.
So
my year 10s can do a nice investigation task with factors of numbers because they're so good with factors of numbers. I think they'd really struggle to do an investigation sort of task with standard forms, say, which is a bit newer to them. I think you have to, if you're going to go a bit more of an investigatory approach, I think you need to lower the mathematical content a bit.
It was just it was a thought that came to me whilst we were talking about interweaving stuff. Is there bandwidth for that? Is it a useful thing that we should be? I mean, we've got the curriculum, haven't we? We've got to get students ready for GCSEs at the end of year 11, and we've got so many hours to get through so many things. But it's, there we go. That was I'll shut up now.
Don't have to do it by them doing the questions that are going to be on the exam paper.
Absolutely not.
At least not all the way through all 2 or 3 years or 5 years, depending on how your school teaches it. I think there's a lot to be said for just teaching them maths and then focusing more on the questions, like the specifics that they're going to see in the exam, nearer the exam. If they're fluent at it, it's not going to make a difference. And I think these tasks and even this investigation, just they're doing maths.
And what I like about this investigation in particular, and what if I made more, I try to make it similar, is people's never wandering blindly in a dense forest of mathematical confusion. There's a bit of a path they're kind of led down, and the investigation prompts you should see on the screen are not there to be shown to pupils. They're there for the teacher to guide the investigation. And I think it's low floor enough that everyone can be engaging and climbing up in a positive way. And I think you've got to be careful with investigations that they don't become
you don't want to be.
Kids can just work it out. Everyone else is just lost and not really getting anywhere. So I think you have to be careful, but I think this sort of task where you can structure it a lot more while still maintaining that kind of exploring.
Yeah, you don't want to leave them abandoned just with here's a mathematical thought, go and explore it.
Writing of triangles, play about with them. Come back to me in a few hours.
Yeah. If only
in the case of Beyond Pythagoras, go find the website that lists them all, then write them out in a long line, then spot that it's a quadratic sequence. There we go. Hand it into your maths teacher, get full marks. I mean, talking as someone who marked it, so just to make me feel old, Helen, telling me you did it at GCSE.
There we go. That dates both Karen and I. Points if you can work out how old we both are.
They do they have coursework in the IB, International Baccalaureate. They have the integrated assessment, and they choose what they want to do.
But they choose what they want to investigate rather than the older style GCSE coursework where it started off in a specific here's a problem to start you off and then develop it further. And the mark scheme essentially assumed that they were written in such a way that every student went in pretty much the same direction.
When I did that coursework, Google wasn't a thing. So there was no Googling Pythagorean triples. We did have to work them out. There you go. More clues to date me. Sorry. It's just I've got my international student will be working towards the IB eventually. I know, they have got their project, and it just fascinated me that we talk about wanting real world applications of things and using the skills, and how an investigation like this actually helps students, even if we're nudging them along, even with those prompts that you can give them, to actually think mathematically about something. It's not the actual maths that we're aiming to get them to at the end. It's the thinking, the process. If this is what I've got, how do I investigate it? How do I look at something differently? How do I use the skills that I've got? It's that side of things. I think that's the benefit, isn't it, in investigations? It's not just the subject matter. Or did I awkward silence?
No, yeah, there's in some way there's like a scientific and mathematical process. There's a conjecture, hypothesis. You test it out, and structure it, and then report it. Yeah, your written communication has to be good. So there's a whole lot of stuff that goes on with those investigations, and they have to do that in science anyway. You have to describe an experiment, and that typically is a 6 marker at GCSE, and they have to have quite a bit of depth in the answer. And there's a QWC marks.
There definitely is areas for improvement with how we develop kind of that mathematical mindset that you talk about. I don't know how your experience is with Key Stage 5, but my experience teaching Year 12 is, gosh, they run scared from a proof question because they've never been forced to think through so carefully and describe so carefully what they're doing. And that mathematical mindset, which to me is so fundamental to what doing maths is. Like, if you can't prove, in my mind, you can't really maths. Like, that is so key to doing maths, is that rigor, that presentation, that formalization of your understanding. And they struggle so much with that because it's not something they're so used to just doing questions. It's
dripping into the higher, isn't it? There's a little now that's in the higher tier. And I mean, it's a very simple 2 consecutive terms, 2 consecutive numbers prove that it's even kind of level of, I think that generally is the question that I've seen on the last, or something similar that you have to, so they have to know to get an even number, you do 2n, or an odd, it's 2n plus 1, and then you're squaring it, or you're adding it, or you're doing whatever it is to those terms. But yeah, it's, my A-level students don't like it.
I mean, it needs to filter down all the way to primary. We don't have anyone primary today, but when I'm doing you can do visual proof of even plus even is even with the number blocks. So you get those number blocks, and you get even ones which are the same. It's like an array, and then you join them up. It's like a Lego, and then you got another even, and so if they've done that kind of thing for quite a long time, all the way through primary, then the algebraic proof, or the proof as an idea, doesn't feel as daunting.
See, that's interesting, because when I did my masters, I did a proof, a proof essay and stuff, and I got Year 7 through to Year 11 to prove that 3 consecutive numbers were a multiple of 3, and the younger students could explain it better because they could do a visual proof. They were like, oh, I'll just take one off here, put it here, they're all 3 the same size. When you then gave it to the Year 11 students, they automatically wanted to do it algebraically, and then they fell over a bit. And it's like, because they went for n plus 1, n plus 2, and then got 3n plus 3, and then felt they had to write sentences and sentences to explain why that was a multiple of 3, rather than going for n minus 1n and n plus 1, which would have fallen out nicer, or even realizing that they could just factorize and get 3 multiplied by something else. And I think actually when we start introducing algebra proof to students, they lose some of the visual. They forget that they had visual proof. They could prove it visually before they knew how to do the algebra. It's one of those sort of like, oh, just reach for algebra now because I know how to do algebra, without realizing. And I'm guilty of that all the time. Like, my preference when someone sets me a puzzle is I will turn everything into algebra. And actually, that's not always the best way to do things. I mean, Nathan will tell you, like on ratio, it's like, actually, there are a lot easier ways to do a lot of the ratio questions, but my automatic assumption is I just write it as an equation and try and solve it. I don't care if I've got like 6 unknowns. If I've got 6 equations and 6 unknowns, I know it's going to fall out. I'll just chug through all the algebra and hope I don't make a sign error in the process. But actually, I probably didn't need 6 equations and 6 unknowns. I could have probably just looked at the numbers and thought about what was going on, and actually it would have fallen out easier. And I think but I think Nathan's point about presentation and signposting is the phrase I like to use with the A-level students. Like, are you signposting your solutions? And the point Nathan meant earlier about going through an example with the students when they're doing an interweaving question, and going through, like, okay, so I'm going to find the length of this side, and I'm going to write down that I found the length of this side, and then I'm going to find the length of this side, and I'm going to write down I found the length of this side, then I'm going to find the areas, and I'm going to write down that I found the areas, so that I just don't have a page of maths math. I've actually got a signposted solution. And I think that's actually something that these can be really useful for, because they are going to be longer solutions than they're used to. We can use them to help students learn that signposting their answers so that they can follow through them and somebody else reading them can follow through them is actually a really big skill. I think that's a skill a lot of students don't pick up well enough, that everything will be right on their page. They'll have a page of A4 maths, but they won't have necessarily signposted where they found different things, or gone, this is where I found the area of the circle, and this is where I found the area of the rectangle, and this is where I've halved the circle, and this is where I've added them together, and now I've got my compound area. And
yeah, I think that's because
they get it, don't they?
Throughout GCSE, they're kind of led to believe that a show that question, or a question that says show your workings, is just to show your working. Like, it's rough paper that happens to get marks for it. Whereas we want them to be thinking about presenting a solution, like as a complete thing, like you can follow, you can understand that you're showing your method, not just your workings. It's not just the calculations you're doing. It's your method, it's the reasoning behind it. And I think to be able to, as you say, Karen, to encourage that, you need to give problems worth solving where there are those steps of logic that they need to be using. Like, I want them saying, when they're doing the standard form averages thing, why are we dividing by 3? Because whatever we're dividing by how many numbers there are, you need to signpost that, to use your language, show what you're doing and why. And
so I'd say there's 2 points. Yeah, Karen, I find especially something like that where it's a compound shape and you've got a semicircle on top of a rectangle, they'll work out both of them and then go, where have my answers gone?
Which two am I adding together?
Which bit am I putting where?
Yeah.
Whereas if they've written area of semicircle, big circle round, I like to say, and I do always clarify this with students, pretend the examiner is thick. They aren't. They do know what they're talking about. They generally have maths degrees. In fact, they all have maths. They're all maths teachers. They know what they're talking about. But if you pretend that they don't, then you are more likely to say, this is the step, this is the step, this is what I'm doing, here we go. Pretend that I don't know, and then it makes it easier to explain. Then they're explaining what they're doing, which is good to write down, to present it, and then good for them to explain what they're doing so that they learn what they're doing. It kind of that, like teaching somebody that younger than you or less able, reinforces your own understanding. So there's the 2 elements of that.
If you can't write your thinking down, you're not thinking clearly, you're just guessing or doing things subconsciously.
And it means you slow down. Because I can't write faster than I can think or talk. My students will say, I write on my whiteboard and I'm about 5 words behind what I've said because I cannot write as fast as I can talk. That might be because I talk too much, but if I'm having to write it down, I have to slow down. I've got to take the time to make it legible. And if that's the same for me, and I'm a reasonably capable mathematician, I'd like to think, I'd hope anyway at this point, somebody that's less able definitely needs to slow down. Explain it.
And a great way to make people slow down is to give them interwoven questions. They have to think carefully about each step and can't rely on that automaticity that comes from having solved 8 billion similar equations. So you need to subtract, but you don't really know that you're subtracting. Like, I ask people when they're solving equations, where did that number that you've just written down come from? They've got no idea. They've done 24 minus 18 and got 6. They do it without thinking. And that's good, okay. I like to do things without thinking sometimes, but I also need to have the thinking behind it as well, that they can explain if they need to, so that when they get 18 times 10 to the power of 4 and whatever, they can still do the calculation.
Apart from 18 to the standard, 10% to the standard 4.
Some numbers aren't in standard form, they're just written as multiples of powers of 10. That's okay.
There we go. And that's itself is its own little thing to make them think, isn't it?
Yeah.
18 times 10 to the power of 4 is in standard form if you're in base 20. There you go.
Oh, you mentioned different bases. I was like,
oh no, you don't have to go in. We haven't got time.
I was about to go into different bases.
That doesn't work though, because you wouldn't use times 10 to the power of if you're in base 20. It'd be times 20 to the power of.
It's Thursday evening.
Yeah, exactly. Your bases will be different.
Multi-base standard form. We need to make this happen.
I think.
Ow. Is all I can say
Mr.
to
Taylor's
that.
doing it. No, Mr.
Fantastic.
Yeah, he's doing it. He posted up a task. He does a lot of multi-base stuff.
But how many students do we get when it comes to the standard form questions that don't spot that when they've done the calculation, their answer isn't in standard form? 0.63 times 10 to the 4. No, that might be the answer when you've done the calculations, but it's not the last step to.
But I think that often that's cognitive overload, because I think they read the question, they do the question, and they don't go back and then read what form do I need my answer in. The same way that students don't round to 3 significant figures when you ask them to, or don't simplify a fraction. It's because they've thought so hard about doing the question, done the question, that actually the form of their answer is something they would have to go back and read the question for. And they're not in the habit of then going back and checking, is my answer in the correct form? I mean, that's,
absolutely. And you know what's great for helping students build the ability to keep more than one thing in their mind at the same time, to keep track of those different parts of the question? Interweaving. Okay. Yeah. Interweaving's great at that, because it makes them have to consider those jumbled, like if you're doing that L-shaped area thing, you can't forget halfway through what you're doing, because you will be lost. You need to be able to keep track of those things in your mind, or have a way of writing them down clearly so you don't forget that you're running an area.
Yeah, I'm sensing a theme coming out here, just somewhere in our conversation, that maybe we might be doing some interweaving.
But that's what I found about the area task, was they were actually writing down their steps for their compound area, whereas when you give them integers, they can hold most of those numbers in their head, and then if they make a mistake, all you've got is a number on the page, and you're like, I don't know where you've gone wrong, you don't know where you've gone wrong, we need to start the question again, and I can't spot where your misconception is. Whereas because these numbers are such that you can't keep them in your head and you are having to write them down, I can see that you are reading the numbers off the wrong side to multiply, or I can see that you aren't bothering to subtract, find the missing length when you need to. And actually, so that, another advantage is that for things like that, it gives you a chance to spot misconceptions that you can't specifically see when students are saying, oh, I just know the answer, because they know that 3 times 8 is 24, and they've done a multiplication wrong in their head and not realised, because they were trying to beat their neighbour and get to the end of the questions first. And the way to do that is just to write down all the answers as quickly as you can.
The question is also nicely self-checking, because if you get to a horrid answer, you've done something wrong. Whereas if you get to 4, when it looked like it was going to be a mess of fractions and decimals, well done.
So note to self, Nathan doesn't give disgusting answers, just disgusting numbers in the questions.
Nathan regularly makes mistakes though, so sometimes they do have disgusting answers.
But then if all the class have got a horrid answer, then it probably is the horrid answer. But if one student's got 7/12 and everybody else has got a half, then that student that's got 7/12 has probably made a mistake, rather than the other 90% of the class having made the mistake.
But again, us making a mistake on the board, deliberately or not, is a good way for getting...
Never deliberately. Never deliberately.
No, never deliberately.
Whatever we may say to the students, it's never deliberately.
I was just watching to see if you'd spot my mistake there. But it makes they're watching, they're dealing with the load, isn't it? If we've got a disgusting number at the end, then we've likely have made a mistake somewhere along the line. Not dead certain, but likely to have. My maths teacher, when I was at sixth form, had a standard rule that if she made 3 mistakes in the lesson, she brought the cake to the following lesson. I don't think it happened during my 2 years at sixth form.
Can I do that in reverse? If my pupils make 3 mistakes in a lesson, they have to buy me cake.
No, I think the standard form was...
I think I'll do better.
We all took turns in bringing the cake, but if she made the mistake, it was her turn to do it, or something like that. Again, it was a few years ago.
I've heard that some teachers have some wacky raffle system for who has to bring in the cake.
To be fair, I end up in the raffle when I make a mistake, so it works, right?
Lovely. Yeah, so we're coming towards the end. I'm thinking of, you started off by saying interviewing is not just in maths, it can be across all the subjects, quite a lot of domains. And I think for one of my favorite ideas that I saw this in a Brian Cox documentary, and he started it off with, why do bats eat so much? And it came to the idea that larger animals, it's to do with the surface area to volume ratio. So small animals like bats and mice, etc., have a more surface area compared to the volume. So then the rate of heat loss, so that's another rates thing in there, physics and maths, is more, and because the rate of heat loss is more, they need to generate more heat. So generate more heat, then metabolism has to be higher. So for the metabolism to maintain to be high, they need to eat a lot and eat it pretty frequently. So Yeah, and it's so the interweaving is not just in the maths, and it's like the more you learn in life, the more you relate it to their experiences, and it's about making connections with things and making meaning, and it requires effort. Yeah, so.
So Nathan, you need to do a final plug to get people to write some, so that you don't have to write all of the ones for the website.
Please make tasks. If they're rubbish, don't worry. That's fine. We'll work on them together and we'll do our best. And I like the ideas, even if you've not got time to make their questions. I love getting the ideas. Just send me a message on Twitter if you've got an idea or got a task you want to share, or there's a contact me page thing on the website at interwovenmaths.com. Yeah.
Excellent. Yeah, so the power of community. And we tutors can test it one-on-one. If you don't want to use it with the whole classroom, it can be
you can spot the mistakes in them.
Yeah, so we're always hungry for tasks. Maths teachers, tutors, we're hungry for tasks. Just make more, give us more. And due respect to all the examiners who come up with these questions as well, there's quite a skill set coming up with like the Hannah Sweets type questions.
And one thing to note on the task is they're all fully editable PowerPoints. That's really important to me, that any teacher or tutor that wants to use them can edit them to what's suitable for the people they're using them with. And if they want to make improvements, go right ahead and edit to your heart's content.
Brilliant. There it is, interwovenmaths.com. Thank you for your time, and hope to see you again on another Maths Chat Live. This will be recorded, so if you're listening to the recording or watching the recording, keep the conversation going. Just reply to that tweet. Keep our ideas coming. Keep posting any tasks.
Don't stop interweaving.
Yeah, interweave. Yeah. We interweaved it with last week's. I haven't got one plan for we got complex numbers, introduction to complex numbers coming up. So, yeah, interweave them with whatever, vectors, averages.
Oh, complex numbers that's a good one for interweave. It's got a lot of links, which is nice.
I think complex numbers in standard form is the way to go.
Some level examiners already thinking about that, making a question up now. Brilliant. I'll call it an end now. I'll hit the stop streaming button, and then we'll just have a quick chat and we can say bye. So I'll ask everyone to say bye-bye for our last